Swayam Prabha. Digital India. Educated India.
In this session, I will discuss the various aspects related to GIS data input and its characteristics. Geographic data in digital form are numerical representations of the real world. It describes the real world features and phenomena coded in specific ways in support of GIS and mapping applications using the computer. The digital geographic data must be organized as a geographic database. Roughly two-thirds of the total cost of implementing a GIS involves building the GIS database, which should be accurate and has significant impact on the usefulness of the GIS. Now, GIS data types can be categorized into two types of data. One is spatial data and the other is non-spatial data. So, now let us look at what is spatial data. It gives information about the geometric orientation, shape and size of a feature and its relative position with respect to the position of other features. Spatial data is described by its x and y coordinates. The spatial data is normally available in analog form as maps, but now these maps are also available directly in digital format. In GIS, both types of spatial data are handled differently. Normally, the spatial and non-spatial data are stored separately in a GIS and links are established at the time of processing and analysis. Now, let us look at what is non-spatial data. The non-spatial data, also known as attribute data, are information about various attributes like length, area, population, acreage, etc. The non-spatial data describes the attributes of a point or along a line or in a polygon. In other words, they describe what is a point, that is a hospital, or along a line, that is maybe a canal, or in a polygon, that is maybe within a forest area. The attributes of a soil category may be depth of soil, texture, type of erosion or permeability. The non-spatial data, mostly available in tabular form, are also converted into digital format for use in GIS. Having had an idea as to the various broad categories of GIS data types, let us now look at the data representation. The data representation is in different kinds of variables, also known as scales, that can be stored in a GIS. These variables are nominal, next is ordinal, then internal and last is ratio. So, look at these variables by which GIS data representation can be made. Nominal variables are used when the data are principally classified into mutually exclusive sets or levels based on relevant characteristics. The nominal variable is the commonly used as a measure for the spatial data. it can be of two types, that is dichotomous or categorical. So, let us look at dichotomous. This is basically a representation in terms of the presence or absence. So, we can say these data are mainly logical definitions of a data characteristic and are also referred to as yes or no data. It mainly applies where a particular data is to be classified into one of the two categories. For example, a village may or may not have a hospital, or a city may or may not have an airport. So, in these cases, the representation of the information would be that a village, if the attribute is hospital, then it would be defined as, if it does not have, then it would be defined as no, if it is present, then it would be yes. Similarly, in case of a city where there is an airport, the representation would be in the form of yes, or else it would be in the form of no. Now, let us look at the next subcategory of nominal variables, that is categorical data. These are used when it is required to classify the data into one of several categories by name with no specific order. A very typical example could be categories of land use into residential area, recreational area, business area, or a representation of tree categories such as Curus agrifolia, Pinus coulteri, Acuplitus, Calophilia. These are different kinds of categorical variables which are there, wherein the minute definition of the information is provided. However, the order in which they have been specified may not be in a logical or sequential manner. Then we come to ordinal variables. Ordinal variables are lists of discrete classes, but with an inherent order or sequence. This representation of data is more sophisticated and orderly, as the classes are placed into some form of rank order based on a logical property of magnitude. The ranking of data may be natural, such as grades of agricultural land, or according to some criteria such as population density. In general, classes of streams may be first order, second order and so forth, or levels of education may be primary, secondary, college, postgraduate. All are ordinal variables, since the discrete classes have a natural sequence. Then we come to the next type of variables, and that is internal. Internal variables also have a natural sequence, but in addition the differences between the values are quantified. For example, the elevation of points is an internal variable, since the difference in elevation between 2 points having elevation 55 meters and 65 meters is the same for other points having elevations of 80 meters and 90 meters. The representation of the population in the same order is an example of internal variables. Then we come to the last type of variables, and that is ratio. Ratio variables have the same characteristics as the internal variable, but in addition they have a natural 0 or a real origin, that is a starting point. per capita income, the fraction of a weight of a soil sample that passes through the sieve are common ratio variables. Having had a look at the representation of the data in terms of the manner in which it can be designated, now let us look at the different types of data sources from which the data can be extracted and converted and stored into a GIS environment. So, these data sources could be satellite imagery, existing maps, aerial photographs, digital orthophotographs, attribute data, survey data and records, and other sources. So, let us look at each of these data sources one by one. Remote sensing data in the form of satellite imagery is an important element of the organization of any GIS database, as it makes possible repetitive coverage of large areas. Satellite imagery can be used as a raster backdrop on a vector GIS data set. Satellite images can support numerous GIS applications, including environmental impact assessment, site evaluation for large facilities, highway planning, development and monitoring of environmental baselines, emergency and disaster responses, agriculture and forestry. Satellite images are also useful for urban planning and management. In addition to image analysis, satellite images are used to generate thematic information, resulting into thematic maps. The next data source is the existing maps which are there. Paper maps are the most important source of data for GIS. Maps of various scales, sizes, formats and time periods showing different features are available for large portion of the earth, and these are major sources of data for the GIS database. The information available on a paper map is converted into digital form by the process of digitization for use in GIS. Advanced countries like USA also have digital maps, which can be directly used in GIS without going into the process of digitization. Well, this saves a significant amount of time for the analyst when he is creating such databases from paper maps. The next data source could be aerial photographs and digital orthophotographs. Well, this is another major source of data for GIS application. Aerial photographs rectified for relief displacement or radial distortions are also known as orthophotographs. An orthophotograph is geometrically equivalent to a conventional line map and represents planimetric features on the ground in their true orthographic positions. To simplify, this is a data product wherein the elevation of the ground or of an object is compensated and only the plan view of the informations are depicted, and thereby it becomes very similar to a paper based map. So, due to these, orthophotographs possess the advantage of line maps, such as ability to make measurements of distances, angles and areas. However, orthophotograph, unlike line maps, also contain the image of an infinite number of ground objects, and therefore, most of the time they need conversion into thin maps. At present, with the given computer power, its storage capacity and speed, it has become possible to have digital orthophotos commercially. The digital orthophotos provide all informations of a photograph, but at the same time allow the registration of vector maps used in GIS. Next is attribute data. Attribute data for a GIS are mainly tabular data collected by sampling. The tabular data, which are tables consisting of rows representing the samples and columns representing parameter values, can be incorporated into a GIS as relational tables. The next type of data source could be survey data and records available at various places. Sometimes survey data and records about rock types, soil types, elevation, population and other features are collected by the related national agencies of a country and maintained in the form of tables and maps. These data can be incorporated into the GIS. Along with this, there are other sources from where the data related to a particular location can also be acquired. Conventionally, terrain data can be obtained by field surveying using grid leveling, stadia tachymetry or other field surveying based methods. These methods have been replaced by new generation surveying instruments such as electronic tachymeter or total station and the global positioning system or GPS for collecting locational as well as attribute data. Another source of GIS data could be the internet. It has been found that many agencies provide free access to data or maybe a nominal fees may be required to access to these data, and thereby it saves lot of time and energy, because this eliminates the replication of the efforts to collect the data. Similarly, these data sets once collected by the GIS analyst or user, he can subsequently share this information through the internet, so that another person who may be working in this particular area may use this information, thereby saving lot of time. If you recall, right at the starting I had emphasized that about 2/3 of the time is required for creating a proper and accurate GIS database. Almost all analog or digital data available for use in GIS may have limitations and pose problems while organizing the GIS database. It has been observed that when specific activities are being carried out within a GIS database, it is possible to make a comprehensive designation of the different types of data sources which may be required in order to provide a completeness to the GIS database. So, by and large, the most common application of GIS is the effective management of natural resources and plannings of regions at different levels. So, these require a variety of data sets. Well, these data sets can be grouped as below: natural resource data, demographic data, agroeconomic data, socio-economic data, infrastructure data. So, let us look at each of these comprehensive data sets which are there. First is natural resource data. Well, it may consist of the following data informations which may have been acquired from various sources, either from satellite or through field survey or through use of aerial photographs, or it could have been made available from the internet. And these could be the land use of that particular area, the different type crops which are being grown, the total crop area, what are the water bodies and the drainages which are existing, soil types, forest types, groundwater potential, mineral resources. Then the next type of data could be your demographic data. Well, this type of data may consist of information related to the population in the region, what is the age structure, what is the sex ratio, what is the urban and rural population, the reserved caste population, the occupational structure and migration patterns. If one really recalls, the present day census data collection in India tries to accommodate all these informations so that they can be used for various activities wherein infrastructure development planning and projects have to be undertaken. The next type of data could be the agroeconomic data set. Well, these data sets could be what is the cropped area and the irrigated area, what type of agricultural holdings are there, what is the land holding which is there, the livestock population, the livestock produce which is there, location of markets and pricing information. The next type of data set could be related to the society and its economic impact, and this is known as the socio-economic data set. Here typical informations related to the industry located in the area, what type of fishing activities are taking place, tourist development potentials can be identified or provided. Then the beneficiaries of various schemes. It may be recalled that the government from time to time announces different types of schemes for people. One of the very important schemes at present which is being implemented by the government is the NREGA scheme, which entails that there should be a minimum of 100 days of income in the rural domain. So, one may be interested in finding out the success of such national level programs which are there, which would mean that one must have access to this type of information, that is, who have derived benefit from such schemes. Further, in a given region there can be many such schemes, and thus it would be good to know that what are the various programs of developments which have been implemented in the past or which are running in the present or may be implemented in the future. Another important data set is the infrastructure data. Well, the infrastructure data may include various facilities, utilities and services such as education, health, power, transport network, water supply, communications, general amenities and drainage. The user, when he now tries to look at all these data sets in totality, probably the user will now be able to understand the level of information that may have to be acquired for a GIS project, and the same needs to be also implemented into the GIS database. If there is a absence of any information, it could lead to a improper decision making, and thus some of the analysis results may not reflect the true picture or give the true scenario for which it may have been implemented. So, having looked at all these data sets which are there, which could be an input into a GIS environment, naturally now one has to look at the different forms of data acquisition. Data acquisition in GIS refers to all aspects of collecting spatial data from all available sources and converting them into standard digital form. This requires data such as an interactive computer, a screen and mouse, digitizer, word processors, spreadsheet programs, scanners and other devices necessary for reading data already written on magnetic medias such as tapes or CD-ROMs. Well, the sources of data which could be subjected to various forms of conversion could be from remote sensing, existing maps, photogrammetry, field surveying methods, GPS and internet. So, let us look at these data sets which would be used to extract the information and stored into a GIS database. The terrain data acquired through sensors on board satellite platforms being in digital form can be directly used after pre-processing for preparing a GIS database. These data are coded in picture elements called pixels and stored in the form of a two-dimensional matrix that contains merely a number representing the amount of the reflected energy radiation received in a given band. The digital images must be located properly with respect to a geodetic grid, otherwise the data that they contain cannot be related to their true ground positions. The next is existing map. The acquisition of digital data by digitizing existing maps is comparatively cheaper and requires less time compared to other methods. The elevation data extracted using contours have poor accuracy as compared to spot heights. The digitized contours cannot be used for any useful GIS applications other than regenerating the original contours themselves. The digitized contours cannot be used for any useful application other than regenerating the original contours themselves. For the digitized contour data to be used for digital terrain model, it is necessary to carry out a series of post digitized processes whereby sampled net points are used into triangulated irregular network or digital elevation models or DEM. The digitization of paper maps is done using a spatial data capturing device called a digitizer. Map data conversion by scanning and vectorization is often referred to as a screen digitization or heads up digitization to distinguish between the conventional data conversion using digitizers. This approach of digital data conversion is capable of converting a large number of maps in a relatively short period of time and at a cost comparable to or lower than the conventional method of map digitization. The next source from which data could be extracted is photogrammetry. When the area of interest is too extensive or too rugged, the photogrammetric method is employed to collect the digital terrain data using appropriate photogrammetric instruments such as analog stereo plotter equipped with encoders, analog plotter or using digital photogrammetric methods. Analog stereo plotters provide 3D data from aerial photographs. The digitization of 3D models of the terrain found by analog stereo plotter is done by equipping the stereo plotter with linear and rotary encoders. The next method could be field surveying methods. The terrain data in digital form can be obtained directly by field surveying methods by employing instruments such as electronic tachometer or total station and GPS. The electronic tachometer or total station is capable of electronically measuring both angles and distances and performing computations to obtain horizontal distance, slope distance, difference in elevation, coordinates and elevations of points. These equipments are equipped with internal memory or external data recorder for temporary storage of data, which subsequently are transferred to dedicated microcomputers or mainframe computers. The next source from which the data acquisition could be done is the GPS. GPS is a satellite based surveying system to obtain highly accurate digital terrain data electronically in the form of x, y and z coordinates. There are two basic field methods of GPS measurements, that is static and differential. Static GPS surveying is used to determine the positions of survey control points in area where geodetic control is lacking or unreliable. It is also used for accurate measurement of distance between 2 points using 2 or more dual frequency GPS receivers to record the observation made on GPS satellites simultaneously for 6 hours. Static GPS surveying is mainly employed for establishing geodetic control and measuring national and international networks and are not intended for ordinary detailed terrain data acquisition. That is to say that this is to be used for global areas and not for small local areas. Differential GPS surveying is used to determine the positions and heights of ground points by making use of existing or newly established control points. The differential GPS surveying may be performed as a kinematic GPS surveying or real time GPS surveying. As we have already discussed earlier, Internet is a vast network of digital computers. They are linked by an array of different data transmission media such as a satellite and radio links, fiber optics, unshielded twisted pairs, coaxial and telephone communication lines. Connecting these media involves an array of different devices ranging from complicated routers and data switches through simple signal amplifying hubs to modems. The transfer of data is carried out by using a standard coupling protocol known as TCP/IP, or the full form is Transmission Control Protocol or Internet Protocol. For GIS users, the www, that is World Wide Web, provides data and is a source of information. Whole libraries of vector, raster and object data are being offered by the internet as well as directory informations on different data sets. At the moment, the speed of data transmission and internet access are the main limitations of this data resource. With this, I now conclude this session, wherein we have just looked at the various types of data input, its representation, its characterization, then the amalgamation of data sets into certain information databases, and subsequently the acquisition of information to be so that it can be now made ready into a GIS database. In my next session, I would focus my attention to data verification and editing for the removal of errors. Thank you.